All right. Let's see. So quick look at this. This is a problem like 15? Okay. So the numbers in this are bigger. That makes it harder. If you've got access to a calculator, it shouldn't be that hard. You can still solve it. It has the same structure as the other problems that we solved. They have two square roots and then one term that's not underneath the square root. So it doesn't really matter how you approach this. Although if it were me, I would probably, let's see, I'd probably move the 9 over so that it's positive. So we're going to have 19x minus 71 plus 9 equals the square root of, x plus 316. And then we're going to square both sides. So this side is x plus 316, right? And this side over here, we get a perfect square of that, so that's going to be 19x minus 71. We get a perfect square of that, so that's going to be plus 81. And then we multiply these two together and double it. So if I have 9 of those and I double it, that's going to be 18 square root 19x minus 71. Everybody good there? So if I multiply these, quiet please. If I multiply these together, these are all going to, whenever you square these two binomials, it's always going to produce a perfect trinomial square. So if you have a plus b quantity squared, you're going to get a square of the first one. It's going to end with a square of the second one, and then you multiply the two of them together and double it to get the middle term. So that's going to be plus 2ab. Everybody remember that? So that's why when I multiply these two together, radical 19x minus 71 times radical 19x minus 71 is 19x minus 71. When I multiply these two together, that's 9 times 9, so that's 81. And when I do this and this, that's going to be 9 of these radicals. That's going to be another 9 of those radicals, so that's going to be 18. Any questions there? Okay. All right, thank you very much. Appreciate the confirmation. Yeah.
I think, what you do with the 9 is made it way easier, because I did it while 9 was a negative, and it came a little harder for me.
Yeah, if you can avoid working with negatives, it's not that there's anything wrong with them. I mean, it's just that people tend to make more mistakes than when they're working with negatives. Okay. Will you pull the door shut?
Does it matter which side the 9 is on?
No, it doesn't. Okay. The only reason I moved it over there is because it's positive, and it's generally easier to work with positive. That's it. Okay.
So it's just the easiest path.
In my opinion, if you don't want to do that and you don't like that, that's fine. As long as you're getting the right answer. Okay. So from here, the next thing I'd do is I'd isolate that radical. So I'm going to keep the 18 radical 19x minus 71. And then I'm going to move this over here, so that's going to be a minus an 81. I'm going to move this over there, so that's going to be plus a 71. Everybody good with that? And then I'm going to move the 19x, that's going to be a minus 19x. So I've got minus 18x, and if I put these together, that's really a minus 10 there. So that's going to be plus 306. Now, would I want to divide everything by 18 here? Well, grab your calculator. Let's check and see. 18 goes into 18 evenly. That's great. Does 18 go into 306 evenly? If it does, we're in really good shape. If it doesn't, let's not divide by 18 because then we'd be working with fractions. So somebody got their calculator handy? Goes in 17 times. Goes in there 17 times. So this is going to be radical 19x minus 71 equals, this would be a minus x, and this is going to be a plus 17. Good there? Okay. Now, I'm going to square both sides. This side is going to be, let me switch colors here, 19x minus 71, right? Square this, square this. This is going to be a perfect trinomial square. It follows this pattern right here. So what do you get when you square negative x? X squared. What do you get when you square 17? Say 324. I just made that up. I don't know what it is. No, I'm pretty sure it's 324.
289.
Dang it. 289. Okay? What's that middle term? It is going to be minus 34x. And once we get to here, this is now a quadratic. So you've got this to solve. 0 equals x squared. Let's see, if I subtract 19, that's going to be negative 53x. And if I add 71, 360. And then I look for numbers that multiply to be 360 that combine to be negative 53. Okay, and I believe there are some that do that. What's that? Yeah, I think it's 8 and 45. Is that right, Charles? 8 and 45. Charles told me. Okay, they both have to be negative, right? It's a fabulous test question. Just kidding. I wouldn't give it something to you like that on the test. I don't know why they give you problems like that in Math Excel. It's a computerized program. It just what? I'll give you one like this, but it won't have as many parts to it, and it won't have as big a numbers. I'm not going to give you a problem with 316 in it that you have to square or something like that. Yeah.
Just putting it out there. Math Excel kind of put the process a little bit different.
That's okay. What did they do?
They on the bottom before you divide it by 18, they took the square root of everything.
That's stupid. David? Just for you, David?
And for me.
Okay, I'll let you do it, and I won't let anybody else know, okay? All right. Okay. All right. All right. So this section is called Formulas Involving Squares and Square Roots, and there are a ton of them. You're already familiar with a few of them. Let's take a look at this diagram right here. This is the Pythagorean Theorem. It relates the sides of a right triangle. It has to be a right triangle in order to use the Pythagorean Theorem. Let's make sure we're clear on what the names of these are. This is A, this is B, and this is C. Okay? That side over here has a name. What's it called? Okay, this is called the hypotenuse. Okay? And these two are called legs. So if you square each leg separately and then add them together, it should equal the square of the hypotenuse. Okay, you've probably used that dozens of times already. The two short legs of the right triangle have to equal the long leg squared. All right, so, and again, normally we use A and B for the legs, we use C for the hypotenuse. So if they just tell you, and you've got some problems like this, if they just say A is 5 and B is 3, this is what you do. A is 5, that's going to be 5, that's going to be 3. What we're missing is C. So we do A squared plus B squared equals C squared. So that's going to be 5 squared plus, thinking ahead here, 3 squared equals C squared. So this is going to be 25 plus 9 equals C squared. Now, please don't make a silly mistake. Okay, on the test that's coming up, when is that test again?
Monday.
Test is Monday. Okay, you're not going to have access to a calculator. I'm not going to give you any gigantic problems. Okay, there's nothing that where you have to square 316 or take 442 and divide by 21 or something like that. Okay, all fairly easy numbers, and the square roots are pretty easy also. Okay, if you can find like the cube root of 54 or something like that, then you're probably in pretty good shape. Okay, but don't make a silly mistake on something like this and square 5 and get 10. Okay, make sure you're careful. So we add the two of these together. This is going to be 34 equals C squared. So C is, how would we write this? Square root of 34. The reason we get to leave it as the square root of 34 is 2 times 17. There are no pairs of factors. So we just leave it like that. That's it. It's that simple. Okay, so let's take a look at the next one. We've got a leg of 9 and another leg of 9, so it looks like this. 9 here and 9 here. We want to figure out how long this other side is. So that's going to be 9 squared plus 9 squared equals c squared. 81 plus 81 equals c squared. 162 equals c squared, right? And then we have to take the square root. Now, do we get as lucky on this one? Do we have to simplify this, or do we just get to leave it as 162 underneath the radical? No, because remember where this came from. This was two 81s added together. So this is 2 times 81, which is 9 times 9. So this is 9, and then there's a 2 left underneath. So it's 9 radical 2. Good? Okay. I'm not going to do this, but I just want to show you. If they give you a problem where they say C is 10 and B is 8, you're missing side A. So you'd have 10 here, you'd have 8 here, you're missing this guy. So you'd have A squared plus 64 equals 100. Whoops, 100. And then you could solve for A, right? Just move the 64 over. That'd be 36. So the answer is 6. Okay? If I'm taking a square root, why am I not also putting a plus or minus on these? I mean, if I put a square root in a problem, I have to put the plus or minus there also. Yeah. Very good. We're talking about the lengths of the sides of a triangle. They've got to be positive. Greg, did you have a question? Okay. All right, let's take a look at the next one. A right triangle's hypotenuse is 8, and one leg is 4 radical 3. Find the length of the other leg. So just like we were doing up above, here's what we've got. Hypotenuse is 8. One of the legs is 4 radical 3, which looks like we're going to be dealing with a really awful problem, but this actually isn't too bad. Because what do I do with each one of these lengths? Square them. So if they've got a square root in them, if you square a square root, that undoes the square root, so that goes away. So I'd have a squared plus 4 radical 3 squared equals 8 squared. Is everybody okay with that? So this is going to be a squared, and then let's think about what we get here. What does that exponent apply to? It applies to the 4 and the radical 3. So I have to square 4, that's 16. And I have to square radical 3, that's 3. So this is 16 times 3, so that's going to be 48. Yeah, you could do that. Yeah, if you want to. I've never had anybody suggest that, but yeah, that would work. Yep, that'd work just fine. Does anybody want to hear that? Here's what Kirsten did. She said if you've got a 4 on the outside, that's actually 2 on the inside. So you could think of this as radical 48 squared, and there's your answer. That works. Interesting. Okay, and then over here we've got a 64. So I'm going to get rid of that by subtracting. So this is going to be subtract 48. Those are going to cancel, so I get a squared, and this is, let's see if I subtract 48, that's a 16, is it not? So a is 4. So that triangle looks like this. This is 8, this is 4, this is 4 radical 3. Okay. Does that look familiar to anyone? What is that? What is it? It's a 30, 60, 90 triangle. It's a 30, 60, 90 triangle. Okay? So that brings up something else that's really useful. You may have seen these on the ACT. These come up all the time. If you plan on taking trigonometry, it's really in your best interest to get these memorized now. So I'm going to show you where a 45, 45, 90 and a 30, 60, 90 get their names. Make sure we're recording here. Yep, we're in good shape. Okay, so let's run through it this way. There are lots of different ways of describing these, but a 45, 45, 90 is basically half a square. If you've got a square and you draw a diagonal right down the middle of it, this used to be a 90-degree angle right here, same with this one up here, but because we draw this diagonal, that angle is equal to that angle, and this right here is a 90-degree angle. So remember, there's 180 degrees in in any triangle. If I use 90 of them here, there's 90 left between the two of those, and they're equal, so each one of them has to be half of 90. So this is 45, this is 45, and this right here is 90. That's why we call it a 45, 45, 90. And now we're going to do this. Let's say it was a square. Okay, it is a square, but let's say the sides were 1 unit long. How long is the hypotenuse? It's related to 2. Okay, because I'd take 1 and square it, I'd take the other leg and square it, and that should be the hypotenuse squared, right? 1 plus 1 is 2. So I take the square root of both sides, and I get c equals radical 2. So this is radical 2. Now that will happen any time you have a 45, 45, 90. These legs will always be the same. So if this was 10, this would be 10. And guess what this one would be? Square that. That would be 200. 200 is 2 times 10 times 10, so you'd have a 10 on the outside and a radical 2. So this one would be 10 radical 2. So the way we're going to write these down, because this relationship is really important, you ought to know this, we're going to say this one right here is x. What's this other one? It's got to be x. These are always the same. That looks like game. I'm going to get rid of that. Okay? Those are always the same. So if you know one leg on a 45, 45, 90, you also know the other leg. And then on every single 45, 45, 90, if you know a leg, you can find the hypotenuse by timesing by radical 2. So this would be x radical 2. Just like on this one, if these two legs were 10, the hypotenuse would be 10 radical 2, just like we found here. Okay? Okay. All right. If you had the hypotenuse, how would you figure out what a leg is? If you times by radical 2 to go this way, how would you go from the hypotenuse to a leg? Kahala? Divide by radical 2. Okay. Any questions? Okay, let's take a look at the 30, 60, 90. Okay, a 30, 60, 90, we're actually going to start with what we call an equilateral triangle. Okay, and I'm going to say this side is 2, and that side is 2, and this side is 2. If all three sides are equal, how much does that angle, and that angle equal? What do all of them equal? Well, altogether they equal 180, but if all three of them are equal, each one separately is 60 degrees, 1/3 of 180. Okay? So that means this one is 60 degrees. I'm going to focus on this side right here, the solid triangle. If I drop this line straight down here, that makes that a right angle. Since this was an equilateral triangle and I drop this straight down here, what does that do to this side? How long is this little side length here? It'd only be half of the original one, right? Because I could take this side, it looks kind of like a pup tent or something. You can fold that over there. So this is 1. So that's what I've got so far. The only question is, how long is this leg right here? It is. Okay, so we're going to take this and we're going to say a squared plus b squared equals c squared. That's going to be 1 squared plus b squared equals 2 squared. That's going to be b squared equals, let's see, 4 minus 1, so that's going to be a 3. So b is radical 3. Okay, now, you can memorize these numbers, those come in handy, but the pattern works really well. No matter how big or how small a 30, 60, 90 is, they always have this same relationship. So remember, we knew what this hypotenuse was from the beginning. This one is exactly half because you dropped that line straight down. And this one, we multiply that leg by radical 3 because of the Pythagorean theorem. Okay? So here's what we're going to start with. You want to remember this. Everything on a 30, 60, 90 is determined by the short leg. If you know the short leg, you've got it all figured out. If you don't know the short leg and you want to figure everything out, you have to find the short leg first. So here's how it works. Let's do the easy one. If you have the leg, how do you find the hypotenuse? Times it by 2. If you have the hypotenuse, what if you wanted to find the short leg? Divide by 2. And if we have the short leg, how do we find the long leg? Times by radical 3, so that would be x radical 3. And if we have the long leg, how would we find the short leg? Divide by radical 3. So this is a lot of inverse operations here. Okay? Yeah. Oh, sorry, I forgot the x. Very good. Everybody catch that? Thank you, Taylor. Forgot to write the 2 there. Whatever this is, we've got to double it. So if this was q, this would be 2q. If this was 5, this would be 10. If this was a school bus, this would be twice as big as a school bus. Okay? All right. Let's see. I'll leave this right here so we can still see this relationship. And then we just want to figure this out. You have some problems that are literally this easy. Once you know the formulas, once you know these patterns for a 30, 60, 90 and a 45, 45, 90, not only does it make these problems easy, but you're going to be a lot better off taking trig and taking the ACT and stuff like that. So this is a 45, 45, 90. If you know one of the legs, you also know the other leg. How do you go from a leg to a hypotenuse on a 45, 45, 90? Times by radical 2. So this is 14 radical 2. Now let me just say this. If they struggle with something on this, it's usually they can't remember, wait, does the radical 3 go here or the radical 3 go here? They can't remember which one's a radical 3 and which one's a radical 2. They know it's one or the other, but they can't keep it straight. Here's how I keep it straight. The only one that has a 3 in its name, this is a 45, 45, 90. There are no 3's in its name. It doesn't have any radical 3's in it. This is a 30, 60, 90. It's got a 3 in its name. It's the one with a radical 3. Okay? The other thing I ought to point out is this short leg is always across from the short angle, or excuse me, the smallest angle. So that's the 30-degree angle, that's the 60-degree angle, and that's the 90. This is the small side. Okay? That's the long leg. And this is the hypotenuse. The hypotenuse always has to be the longest. Okay? All right, so on this guy right here, we know the hypotenuse on a 30, 60, 90. If you know the hypotenuse, what do you need to find first? Short leg. Here's the short leg over here. It's across from the small angle. So if this is 18, what's the short leg? Short leg is 9. Got that one? And how do you go from the short leg to the long leg? Times by radical 3. So this would be 9 radical 3. Okay? 45, 45, 90. And we have the hypotenuse. How do you go from the hypotenuse to a leg? Divide by radical 3. So if you wanted, I suppose you could write 8 over radical 2. But do we like radicals in the denominator? Generally not, so we're going to rationalize. So we're going to do this. We're going to multiply by radical 2 over radical 2. That's 8 radical 2 over 2. How do I write that? Okay, I can't cancel this 2 with that 2 because that's not really a 2, right? I can cancel the 8 with the 2, so this is going to be 4 radical 2. And if I know that one, I know this one automatically because the legs are always the same. Okay, would you fill in the blanks here, please? Remember, everything on a 30, 60, 90 has to go through the short leg. What one did they give us? They gave us the long leg. So if you've got the long leg, this is easy. Times by radical 3 to get from the short to the long. So going the other way, we have to divide, right? 7 divided by radical 3 is 7 radical 3 over 3. So that's this side right here. 7 radical 3 over 3. Everybody okay with that? What's the only thing you have to do to get to the hypotenuse? Multiply it by 2. Now, does that change that to 14 radical 3 over 6? No. Okay, that's times 2 over 1. You multiply straight across, so the top gets doubled, the bottom stays the same. So there are the answers on that one. Okay, are there any questions? Okay, these are really, really, really good to memorize. You should know those patterns for a 30, 60, 90 and a 45, 45, 90. Okay, so the next thing we're going to do, next formula we're going to cover that has squares and square roots in it is the distance formula, and we're also going to cover the midpoint formula. It doesn't have squares and square roots. It's actually pretty easy. So here's how this works. And you may have seen this done before, but it's always just a good reminder. If you have the distance formula memorized, that's great, but it's always nice to know where it comes from. So we want to know how far it is from here to here. So here's what we do. I'm going to draw a straight line over here, straight horizontal line, straight vertical line, and I'm going to make a right triangle. And my question for you is, what are the coordinates of that corner right there? Don't say anything out loud. We need to find its x-coordinate. It's on this vertical line. It's on that vertical line right there. And I need to find the y-coordinate for this. It's on this horizontal line. It's this far above the x-axis. Ross, what's this one? Yeah, this is x sub 2. That's a little subscript. We just say x2. And what's this y-coordinate? y1. Okay, now, the next question is, okay, if we ignored everything else on the page and just looked at this diagram right here, my question for you is, how far is it from here over to here? It's just a straight horizontal line. It goes from this point on the x-axis to that point on the x-axis. So if this was 5 and this was 2, how far is it between there? It'd be 3. How do you get that? Okay, so what is it? So this is x2 minus x1. That's how long that side is right there. Okay? And then we want to know how long this side is right here. Well, it goes from here on the y-axis to right here on the y-axis. So if I said this was 7 and this was 4, how far is it between those? 3. And you do that by subtracting the 4 from the 7. So how could I represent this distance right here? y2 minus y1. So here's our triangle. This is x2 minus x1. This is y2 minus y1. And we want to know that distance right there. It's a right triangle, right? Even if I didn't make it look like it. There's a leg, there's a leg, there's the hypotenuse. So this would be x2 minus x1 quantity squared. That's the first leg squared. Plus y2 minus y1 quantity squared. That's the second leg squared. And that should equal the hypotenuse squared. But we don't want to know what the square of the hypotenuse is. We just want to know how long the hypotenuse is. So how do we get rid of the square on the D? Take the square root. So I take the square root of this side and the square root of this side. So this is what I get. I get a D over here. And then I get a big square root with all that ugly stuff right there. So I get a big square root, x2 minus x1. And whoops, y2 minus y1. Greg?
Isn't it a bit redundant to put a square root and then also quantity squared?
You mean, do you need the parentheses?
Like in the formula, like the...
Right here?
Isn't it a bit redundant to put the x2 minus x1 squared and take the square root of it and just say x2 minus x1 plus y2 minus y1?
Excellent question. So we've got a big square root and each one of these are squared. Couldn't we just say that this square root undoes that squaring? Okay, let me ask you this. if I took the square root of, let's do 16 plus 9, that's 4 squared, right? And that's 3 squared. So do these undo each other? I'd get 4 from this one, and I'd get 3 from that one, so the answer to this should be 7, right? It's the square root of 25, which is 5. Okay, the reason we can't do that, the reason it's not redundant, is a couple things. First thing is, if you're squaring that entire quantity, you've got to square that. You want to have that quantity in parentheses. The other thing is, this is an addition problem. The minute you throw addition inside a radical, you've completely screwed things up, because then we'd have to actually factor it, because it's not a multiplication problem anymore. Okay? So if it were just times right here, we'd be okay. We could undo the squaring with the square root, and we'd be all set to go. But the minute there's a plus there, end of story. Just like right here, it doesn't work that way. It would be really nice if it did, but it doesn't. Okay? Anything else? You can't distribute a radical into an addition problem, if you want to think of it that way. Because what we did here is we just did radical 4 squared plus radical 3 squared, because it started out like this, and you can't do that. Okay? Generally, you can't distribute any type of function like that. Okay, anything else? Okay, and then the midpoint formula. Midpoint stands for middle point. It's right in between the two. So if somebody says midpoint, think average point, and you'll know what the formula is. How do you average two things? Add them and divide by 2. Add them and divide by 2. So we take the first and the second x coordinates, add them up and divide by 2. There's no minus in there. You're literally just adding the x coordinates and finding the average of the x coordinates. Okay? And you're doing the same thing with the y coordinates. So you add the x's, divide by 2, add the y's, divide by 2, and you're all set to go. So it's x1 plus x2 all over 2, y1 plus y2 all over 2. Okay? Any questions? Okay. So for these points right here, and I've got a couple of them, varied difficulty for a reason, because some of them are easy, some of them are a little more difficult. And you do see stuff like this on Math Excel, so I want to make sure you're ready. Find the distance between the 2 points. Write the answer in exact form and as a decimal accurate to 3 places. And then find the midpoint. Yeah.
For the distance formula, does it matter if you put like x2 minus x1, or you put y2 minus y1 first?
Nope. Doesn't matter. It's literally just the difference between the x's squared and the difference between the y's squared. And the order doesn't matter as long as the x's are with x's and y's are with y's, because you're going to square it anyway. Okay? Good point. So let's do this one. The distance would be x2 minus x1. So this is going to be 1 minus 0, quantity squared. y2 minus y1. Again, just like the slope formula, I said what you ought to do is, write down the negative that's in the formula and then go grab that first y. That's a minus 5, so this is going to be a plus 5 quantity squared. So we get 1 squared plus, let's see, that's going to be 3 squared. So that's 1 plus 9, radical 10. What is it as a decimal? All you have to do is grab your calculator, just type in radical 10. Oops, clear, quit. What was it? 3.162. Accurate to 3 places. 3.162. Okay? And then they want you to find the midpoint. Okay, the midpoint again is just the average, so we're going to take 0 plus 1 over 2. And we're going to take negative 5 minus 2 over 2. So that's going to be 1/2. And that's going to be negative 7/2. Okay? All right. Any questions? Does my writing stink today, Vaughn? Okay. I'll work on it. So let's take a look at this one here. Distance is going to be -3 minus 1, quantity squared. You're just going to blindly write down what I write down? Okay, I can guarantee you right now, there's going to be one on the test where the x1 and the y1 are going to have a negative on them, and somebody in here is going to screw this up. What did I just do? I wrote down the -3, and then I wrote -1, and I didn't bother to think, there's a negative in the formula also. It's a -1. This should be a +1. Okay, please don't make that mistake. It's easy to do. Everybody does it sometimes. You certainly don't want to do it on a test. And then we're going to have y to -5 plus 4. So this is going to be, let's see, -2 squared, -1 squared. So that's going to be 4 plus 1. This is radical 5. Any questions? Okay, midpoint would be -3 minus 1 over 2, and -5 minus 4 over 2. And then I'll let you finish that. Okay, let's get to the more interesting ones. Again, you will see something like this on your assignment. Okay, are there any questions? You can change that to a decimal and you can simplify the little fraction there. Good? Okay, let's take a good look at this one. Is everybody ready? I'm going to blow this up so you can only see this problem. We'll need a little bit of space here. Okay. So this is ugly because it's got fractions in it, but we can still do this. So this would be the distance is equal to 5/6 minus 1/2 quantity squared plus -1/6 minus 1/3 quantity squared. Did I get all the signs correct? I did. Okay, I'm going to change this to 6th. So this is going to be, let's see, 5/6 minus 3/6. So that's going to be 2/6. If I do this problem right here, if I get 6, this is going to be minus, let's see, 1/6 minus 2/3. So that's going to be -3/6, and I've got to square this, and I've got to square this. Now, does somebody want to ask me a question? Yeah, should we simplify this to 1/3 and simplify this to 1/2? Not here, okay? Think ahead just a little bit. We're going to have to combine these in the end. If we've already got a common denominator, if they all already have a denominator of 6, let's leave it a denominator of 6. There's something else that's really nice that's going to happen. So this problem looks really ugly. This is 4 over 36 plus 9 over 36, which is what? 13 over 36. Now, can somebody tell me something nice about that? What? What's that? They already had a common denominator. That's good. I still need to simplify the radical, right? We don't want to leave a radical, or excuse me, a fraction underneath the radical. That's right. The denominator is a perfect square. We can find the square root of that. So this is going to be radical 13 over radical 36, which is radical 13 over 6, and that right there is the answer. That's the distance. So even though it started off really ugly, once you get a common denominator, everything, including finding the actual square root, is pretty easy. Okay, and if you have a problem like this, once you've done this, please take note, we already got a common denominator. With the midpoint formula, what do you do with the coordinates? You don't subtract them. What do? You add them. So this is going to be these two added together. So that's going to be 8/6. Okay, this one would be positive. And this one's going to be the two of these. Let's see, that 1/3, that's going to be a plus. Oh, that should be 6. Yep. Oh, did I do that right? Yeah, I did. I just didn't write the 6 there. So this is going to be 1/6. Divide that by 2 and divide that by 2. Would you get an answer for that? Remembering what we did in, I think was it chapter 4 where we dealt with complex fractions? Fraction divided by a fraction. Flip it over and multiply. So we'd multiply by 1/2. So that's going to be 4/6, which is 2/3 for the x-coordinate. Do the same thing here. This is going to be 1/12. There's our midpoint. Okay? Any questions? Okay, can I slide this over? Okay. As ugly as this is, this looks even worse, doesn't it? Because you got radicals there. Zero minus radical 5 quantity squared. 0 minus a minus, that's going to be a plus radical 3 quantity squared. So look what we get. What's nice about these? Square root. Yep, you get a positive 5 here. Make sure it's positive. Square root, you get a positive 3. That's still underneath the radical. There's our distance. Is that right? MathXL take that? Probably not. 2 radical 2 would be the right answer. And here's the awesome part. The midpoint, take the 2x coordinates and add them together. What do you get? Whoops, radical 5. Divide that by 2. Take the 2y coordinates, add them together. You get negative radical 3. Divide that by 2. There's our midpoint. Okay, not bad at all. Any questions? Just last problem, right? Yeah, this one right here. Oh, sorry, I've got one on the next page we'll take a quick look at because you've got a story problem. One leg in a right triangle is 1 meter and the hypotenuse measures radical 2. Find the other length. So it would look like this. One leg is this, the other one is radical 2. Find the other leg. It's 1, right? That fits the pattern. To go from this leg to the hypotenuse, you times by radical 2. The only triangle that works on is a 45, 45, 90. So that other side's got to be 1. Okay, what they just did is, it's a fancy way of describing a 45, 45, 90. Okay, you can write this down or not. I do want you to just at least watch. Let me make this smaller so we got some room to work. It says, during the heat, a 2-mile bridge expands 2 feet in length. If we assume that the bulge occurs straight up in the middle, how high is the bulge? So this is 2 miles from side to side. In the summer heat, it gets longer. It gets 2 feet longer. So that 2 feet, it's got to go somewhere, so it kind of bulges up in the middle. Everybody good with that? Okay, what's the problem if we see miles here and feet here? They're not the same unit, right? So how many feet are there in a mile? Very good, 5280. So halfway across is going to be 5280. And this is going to bulge up. Well, it's going to make it 2 feet longer. What we want to know is, how much higher does it make it? Now, if the whole thing is 2 feet longer, how much longer would this side be? It would be 1 foot longer, right? 5281. So I'm going to draw an exaggerated triangle. 5281, 5280. x, a, b, whatever you want to use. So x squared plus 5280 squared equals 5281 squared. Clearly a calculator problem. Good test question? Nope. How come? I wouldn't give you anything this big on the test because you can't use a calculator. So let's grab a calculator really quickly and do this. So this is going to be, let's see, 5281 squared minus 5281, or excuse me, 80 squared. That's that. And then I take the square root of that. If I don't want to type that number in, has everybody seen that answer button on there? Okay, so I'm going to hit second answer, and it'll find that square root. Okay, let's see. Why does that not seem correct? Because what's that saying? How high would this be? 102 feet. Well, that's quite a trip. Yeah. Yeah.
Would that, technically because the numbers are so huge, wouldn't that make sense? But it's only expanding by 2 feet.
I suppose it could. I'll take a look at it. We'll go with that for now. That seems like a pretty silly problem. That's one in your textbook. I'll take a look at it. Any questions? Okay, got one more section to cover. Thursday and Friday are basically review. If you want to get started on the review, it's already on the website.